All right, problem 15 of our SAT math with our calculators. According to the model, we're using this model we just used in 14. According to this model, what is the best interpretation of 4.3 in this context? So remember, 4.3 equals slope, right? Because we have y equals mx plus b. All right, and I actually went pretty in-depth in this in the last video on 14, so go check that one out. But mx plus b, see how that lines up pretty well with this. We have cx equals y, we have 4.3 equals m, x equals x, and 19 equals b. All right, so 4.3 is our m, which is our slope, equals m, right? So what is the best interpretation of 4.3? So now this would be a good time, because it's talking about interpretation. Anytime we see the word interpretation, it's talking about what this particular model represents. So let's read a little more about what this model is dealing with. It's talking about annual soybean use in China in some volume, it says millions of metric tons, in some amount, right? Between 95 and 2014, between 1995 and 2014. And X is the number of years. Okay, so X equals years. Y equals amount. You can say metric tons if you want. I'm gonna call it amount because it lets me think about it a little more clearly. Okay, so it's saying each year between, this is one of the answers, each year between 1995 and 2014, China uses 4.3 million metric tons. Let's think about that. What would a y-intercept represent? What do you think? So that might give us an answer to cross off, to place in process of elimination. So anytime we have a y-intercept, that's going to be the starting value because our x, the number of years, is 0. So that would be the number of annual soybean use that they started with, right? So they started with 19 million metric tons in 1995. And we see that C, trying to use this much million metric tons of soybeans in 1995, that's not 19. They're using the 4.3 value for that one, so we know it's not C. All right? Now, did they use a total of this many? No. For D, they're talking about using a total of 4.3 million metric tons between 1995 and 2014, but that doesn't make sense, because in order to get that, you'd have to plug in some number and get the value for C of x, because C of x, C, is the annual soybean use, right? So it can't be D either. All right. Now let's see with this. Each year, between 95 and 2014, China's use of soybeans increased by 4.3 million metric tons. Now that seems very similar to A. So let's think about this first part. Each year between 1995 and 2014, that's exactly the same. The only part that's different, it's saying China used 4.3 million metric tons of soybeans, and then it's saying China's annual use of soybeans increased. Okay, so the only difference between the two is this is saying China's using that many, it's using 4.3 million, and for B, it's saying its use increases by 4.3 million. All right, let's think about that. If every year, let's say you have 19 blocks, and every year you're getting 4 more blocks, that means like by this 20th year, between 1995 and 2014, that's 19 years, right? By the 19th year, you'd be getting like 19 times 4 times the number of years, right? Would that make sense? Think about that for a second. So then each year between 95 and 2014, China is using 4.3 million metric tons. Okay. Does that make sense? No, it doesn't. Because C, again, just like D, C is using the annual soybean use. So we can see that because C, C and C, because C gives us the number of metric tons used, that can't also be them using 4.3 million, because then this would give us some answer that's different than C, right? So in C and this 4.3 value, our slope would be the same thing. We know that's not the case, so it can't be A. And we see that our example that we were thinking about earlier, where we have 19 years times our 4.3, or our 2 blocks, so or 1 block we get increased each time, or our 4.3 blocks we get increased each time. That makes sense, right? Because after, let's say, 5 years, you're going to have 5 blocks plus 5 blocks plus 5 blocks plus 5 blocks, right? Or however many blocks you get per year. So that example makes sense here because our annual use must be increasing by that many per year because each year they're getting that amount, right? So our answer is B. It's the increase of 4.3 million metric tons. The other way you could think about that is it has to be something increasing because our slope is either positive or negative. It's either increasing or decreasing. So at this point, we have a linear function, which is always increasing because the slope is positive. So it makes sense to have a value that is increasing by 4.3 million metric tons, which is our answer, which is B.